Yes, we can.
Okay, good.
So, and you are good to begin whenever you're ready.
Okay, I'm gonna leave my video off because I think that might make my audio better. Is that okay?
Yes, that's perfectly fine.
Okay. So, my name is Olivia Logan. I am a creative tech major and computer science minor. And I originally came to Berry as a math major with a concentration in computer science. But I quickly realized that calculus wasn't really for me and that I really just liked the computer science part more than math. So I knew that I wanted to switch to just the computer science minor, but I remained undecided for the major for a while until I started looking through the Berry catalog and I found the creative tech major on there. And I decided to take the 101 class just to see what it was like. And after that, I pretty much knew that I wanted to switch to creative tech because I felt really comfortable in an environment where there was so much innovation happening and so much creativity. That's just something that I've always done my whole life. So I felt comfortable switching to that as a major. And I also found a lot of opportunity to use my computer science skills throughout the major and during a lot of the creative tech classes. So having said that, my plan during this presentation is to discuss the theme that I've developed for my projects over the course of my time at Berry and how this relates to what I'll be doing after I graduate. So at first, it was hard for me to nail down a theme because my projects seem to have a lot of diversity in them. But I attribute this to my interest with both software side of things and physically building things with my hands. So I really like to get down and dirty with it, sort of, but also like to just completely make something software based at the same time. So that's led me to creating a lot of different types of projects over my course of time at Berry. But after talking with Zane, I was able to determine that one thing that seems to really translate across my projects is how I like to use digital platforms to create projects with functional aesthetic design. And what this means for me is that no matter what I'm working on, I always seem to get caught up in the overall aesthetic appeal of the project and how that relates to its functionality. And through this, I found that my passion is to use digital design aspects to specifically smooth out these visual aesthetics and have them transfer over into a physical object. So with that, I'm just going to go through some of these projects that you see on the screen here. So this first project is the smart mirror. This is something that I created for the senior hackathon project, and the goal was to make a project that really went along with this theme anyway, so I thought that would be a good project to incorporate into this presentation. I knew that I wanted to make something that incorporated my passion for both digital design and physical design at a really basic level, as well as my love for computer programming. So I felt like combining a mirror with a smart display would be an easy way of showing this because mirrors are something that people look into every day. So if there's something off with the design elements of it, it'll be really striking and distracting from the overall function of a mirror itself. So to build the mirror, I laid a piece of two-way mirrored acrylic over an old computer monitor. And then I built a wooden frame to go around it. And this acrylic lets things that are displayed on the computer monitor shine through, but you won't be able to tell that there's an actual monitor behind it. And for the software side of things, I decided to use a Raspberry Pi because you can run it just like a computer desktop, but it can sit in the palm of your hand. So I knew it would easily be able to be hidden behind the frame of the computer. And I would be able to download the software onto it that I could load up and just display the visual elements of the mirror. The program I downloaded for this is something called Magic Mirror. And this is a program that was specifically developed for the Raspberry Pi. It's an open source program that lets you customize the content that's displayed on the screen, as well as the layout of the user interface. So for this particular project, I went with a pretty simple layout that just displays the weather and time in breaking these headlines, but because I use the Magic Mirror platform, it gives me a lot of opportunity to go back and add like a lot more advanced features in the future and really get into the more software side of things if I want to explore that later on. So this next project is called Soul Saver. This is a project I did for the intermediate design studio class, where me and 2 other people worked with a local podiatrist to create a project that could help reduce the complications that are associated with diabetic neuropathy. And the idea behind this is that the doctor would tell his patients to wear this boot for a few days, and then they could come back to the office and look at the data that was collected by the boot. And the boot measures the pressure distribution across the foot. So when the doctor takes the SD card out of the boot and loads it into the program that we created, you would see a visualization of the data, just like the images that you see here on the screen. And hopefully he could use this information to see whether or not the orthotics that he's prescribed to his patients are working effectively to relieve pressure on certain areas of the foot. So this device works by using a matrix of sensors across the footbed of the boot. And the sensor data is then interpreted by an Arduino-based board and recorded onto an SD card. And the SD card can then be loaded into the program that we created. And the visualization will be displayed that you can play through, just like a movie, sort of. The main functional challenge that we faced with this was that we needed to create sensors that were thin enough that didn't affect the pressure of the foot. Like, we didn't want to make it worse than it already was. So to achieve this, we used really thin copper tape to create our matrix of sensors. And then we used vinyl backing to hold it all together. And the result of this was a sensor matrix that was less than a few millimeters thick that just went underneath the footbed of the boot. So it was almost unnoticeable whenever you wore it. The visualization was something that I spent the majority of my time working on. I knew that the success of the visualization would be crucial to the usefulness of the project, because you can't really do anything with this device without being able to see and easily interpret the data that was being recorded by the boot. So something that I wanted to make sure and do was make the visualization easy to understand. And that's why I came up with the idea of creating it into like a heat map sort of visual. And that's something that most people are familiar with the Dr. Scholl's things that you see at Walmart. So I knew that it would be easy to understand where hard pressure was being applied on the foot and where there was no pressure being applied on the foot. And to do all this, we used Arduino and processing. Processing was for the visualization and Arduino was to collect the data. This next project is the computer science logo design that I did for the t-shirts that are given out to the computer science students. This is a design that Dr. Hamid asked me to create for some new t-shirts that he wanted to have printed about 2 years ago. And he gave me very specific design elements that he wanted to be incorporated into the design. But the overall design of the logo was up to me. At this point, I'd never designed a t-shirt logo before. So I started this process by looking at a lot of other t-shirts and noting the design elements that made them look appealing, such as the placement of the graphics in comparison to the text and how that all worked together to form a logo. So the shapes you see on the back of the shirt are generated by a program that Dr. Hamid wrote. And the code that makes this design can be seen in the text wrapping around the lambda symbol on the front. And these are the elements that he wanted me to incorporate into them, but they obviously looked a lot different whenever he sent them to me. There was just some copied and pasted code and just like a screenshot of Dr. Racket of the Sierpinski triangle that you see on the back there. So I had to come up with a way to elegantly put these into a logo that looked appealing. So to do this, I used Illustrator to transform them into what you see here. I tried to make the code on the front look like a backslash for the lambda symbol on the front because he wanted that to be really big and pronounced. And so to do that, I just tried to make the text as small as I could, but if you get close up, you can see it really well. But if you're standing from a little bit back, it just sort of looks like a background to the lambda symbol. Like I said, the shapes on the back come from a fractal program, which does multiple iterations of a simple shape to create a much more complex shape. So what you see in the middle of the design is the third iteration of this program. And sorry, my screen just went out for a second. So yeah, what you see in the middle of the logo is the third iteration of this program. On the far left side is the first iteration, and on the far right side is the second iteration. So I thought this would be a good way to encapsulate the essence of iteration into this logo without overdoing it and doing some crazy big Sierpinski triangle on the back. I thought this would be an elegant way of combining it to really show what the program does, but have it still be aesthetically appealing. So after I had everything designed, I used Photoshop to create the mock-ups of the shirts and send them back to Dr. Hamid. And once he had approved the design, he sent them off to be printed, and now they're given out to everyone who takes the 120 class at Berry. So this project is the portfolio website that I created for the web design class at Berry that I took last semester. This was the first web design project that I did where I had total freedom over the content that I included in the website, as well as the layout of the website. So whenever I decided to make it a portfolio website, I knew that I wanted it to be unique as possible and have it stand out to when it was compared to other portfolio websites. And some ways in which I achieved this was by creating a really dark background for the website. That's not something you typically see, especially in portfolio sites. So I knew that this would automatically be striking when you pulled up the web page. And it would help with the contrast of the big white bold text that you see and the colorful images, because I knew a lot of the images I wanted to put on there would have a lot of color in them. So having them on a black background would make them stand out more than if they were just in a white background. And another element that I wanted to incorporate was the desaturated image on the front. Usually people just put like a headshot on their portfolio site, but I wanted to do something a little different. So I decided to do like a faded out desaturated image really big on the as the background. And that's like the first thing you see whenever you pull up the website. So I used Photoshop to create a mock-up for the website. And then I started from scratch with HTML and CSS to try and make a direct copy of this mock-up as pretty close as I could. To make this process easier, whenever I created the Photoshop mock-up, I tried to create it to scale of a typical website. So it would be easy to transfer the dimensions of the layout and the ratios of everything whenever I went from Photoshop to HTML and CSS. And this is pretty out of date at this point. I need to go back and update it, but whenever I worked on this project, I found that this is something that I'm also really passionate about. I could probably spend months and months working on this and I'll never get tired of it. So I was really proud with the outcome of all of that. And this final project is my capstone project that I worked on this semester. The goal of this is to help medical alert dogs better communicate with bystanders during a medical emergency. To do this, I made a harness that has a rope toy attached. So when the dog reaches over and tugs on the rope toy, a text will be sent out to people nearby who signed up for the service to receive these medical alert texts. And in the text, there will be a link that shows the exact location of the handler, so they can click on the link and then navigate themselves to the handler and deliver the necessary aid instead of having to wait and call 911. And to do this, I used IFTTT, which is a service called If This and That. Originally, I was going to have to use PHP and Dane server and all of these different programming languages, but I realized that I could simplify this entire process by using If This and That, by just creating. Can you guys hear me?
Yeah, we can hear you now.
Okay, sorry. But this, yeah, really simplified the process and made it to where I didn't really have to use any programming languages other than Arduino. So that was really awesome. I also had to use Easy EDA for the design of the PCB that you can see here. And those were the two digital platforms that I used in this process. But the functional design of it all was really important as well, because I had to make sure that the harness was constructed in a way that was easy for the dog to wear, and that the dog could easily reach the toy on the side and tug it in a way that wasn't going to affect the dog's overall job as a medical alert dog, but where they still had easy access to it if they needed it. So this is the state diagram for this project. Basically, all you have to do is connect the device to Wi-Fi, and you'll know that it's connected because it'll beep twice. And after that, you're good to go until a medical emergency happens. And that's when the dog would tug on the harness and activate the alert. And that's where IFTTT would go and handle the HTTP request, which would then send a text message to everyone who has signed up for the service. And once the responder has received that text, they could click on the link and then follow that link to navigate to the handler. And that's all for that process. So after graduation, my immediate plan is to work for a company that I worked for over this past summer doing an internship, where they create custom logo mats for companies. They have a water jet that they use to cut out these designs into the carpet and then create logo mats. So what I did was I would get, like, a customer would send in a request and they would send their logo. And I would do a mock-up of the mat, like you see here at the top right. And I would send that back to the customer. And then if they approved it, it would go down to production and would get created into the mat that you see on the bottom right here. So that's what I'll be doing this coming summer. But my hopes for the future is to do something with web design or web development if I can. I found that that's something that I'm just really passionate about. So I'm going to be looking for jobs in that field after this summer. And that's all I have.
Awesome. All right. Thank you so much, Olivia. It was very good.